Hi everybody, welcome to the fifth day of Code Vita coding. And right, so first, on behalf of Fine Mind, Innovative, and with you, let me welcome you for this session. Christmas tree pattern. Let's have a look at the problem statement. Okay, this I have seen quite a long time back, but actually, honestly speaking, I was not interested in solving. But when I knew it was from TCS in the recent days, okay, this problem was majorly helped by one of my colleague, Selva Kumar. So I'm doing really a presentation, excellent job. So he did a lot of help. Most of the things, whatever you see as a PPT, for example, till yesterday, lot of my problems have been helped by Navneet Priya. And the previous problem, what we did right now, okay, you would find that the input majorly had come down from two people, Anandi and Aishwarya. Okay, so I fundamentally head the organization, and these people do a lot of help for me. And do you remember the formula what we did yesterday? Okay, that was from Pranav. So fundamentally my team does a lot of work. So most of you people you see me, unfortunately my team stands behind me, and my team fundamentally is the one which is my strength. So what about this particular problem statement? Go slow, go very, very slow. Only because of this such a strong problem statement, it was kind of putting pressure. But slowly we'll ease it out. The Christmas tree is comprised of the following parts. Stand part. Okay, each part is further comprised of branches. Branches are comprised of leaves. Quickly have a look at the picture, then you will know. Okay, now the last two lines is the last two stars is the stand. And above that we have branches. These are branches, and everything is supposed to be considered as a leaf. Paka? Because you would not, oh my god, stand, leaves, branch. Relax. Okay, so every except for the last two, that is called as the stand, rest of them are called as branches and the leaves. So you can see immediately above the stand you have two branches. Above that we have three. Above that we have five. So you would find, and as the branch grows above, you would find that it becomes broader also. That's all. Okay, how the tree appears as a function of days should be understood. That is, as the days grow, how does the tree appear? The tree would be growing. This is the fundamental rules. Okay, basis that the print the tree as it appears on the given day. For example, say 10th day, how would that be? Is what is expected. So below all the rules, go through the rules. The rule have been once again misunderstood by many people in the world. Has been misunderstood by many people in the world. Okay, so let's go slow. If the tree is 1 day old, it's simple. If they give you one, print a message, you cannot generate Christmas tree. Keep it as simple as that. Okay, that's the most important thing. The crux of any online test is going to be understanding what exactly the problem is. Okay, true. Tree will die after 20 days. It means they are simple. The n what they are going to give you, okay, is minimum of 2, not more than 20. That is what they are saying as the first two rules in their own style. Okay, trees will have one part less than the number of days. Now, why? Because there is a stand below. That is all. So that one less becomes because of the stand. So on second day, tree will have one part and one stand. That's exactly what I told you. One goes for the stand. So on second day, one part, one stand. Third day, two parts, one stand. Fourth day, three parts, one stand. Continue. Fifth day, 4 parts, one stand. Sixth day, 5 parts, one stand. Because if you continue, you will feel happy, and you're right. And the topmost part will be the widest. Obvious. Because it grows. Okay, next. Difference in number of branches between topmost and the second from top will be 2. That is, for example, you look at it. This is 1, 2, 3, 4, 5. 1, 2, 3. So the difference between the first one and this one is 3. And subsequently from that point onwards, 3, 2. So actually speaking, all these are important, but more than that, you would find that it is your feel towards that particular pattern That matters a lot. Understand that. The problem statement per se has got a lot of information. Straightforward, your feel towards that is going to be the one that is going to really matter. Okay, good. So let's have a look at it. Okay, good. First, input in black and white. Okay, all this is done by my team. Day 2, how would that be? So you can see here one part and a stand. Day 3, 2 parts. Part number 1, part number 2, and a stand. Day 4, 3 parts. Part number 1, part number 2, part number 3, and part number 4. So this is how the tree grows. Day 5, if you want to make it a little smaller, or maybe I'll move it up a little bit. Paka? Good. Okay. Day 1, Day 2, Day 3, Day 4, and Day 5 this time. So what have they mentioned? The top one. Okay, and this is the next part. You will find that the difference is 2. So look at this particular part. You will have some amount. For example, you'll count 1, 2, 3, 4, 5, and 6. This got only 1, 2, 3, 4. After that, 1, 2, 3, 1, 2. So you can see that's what they have mentioned. The topmost part and the subsequent part, there is a small gap of the difference is 2. Okay. Trust me, all this will naturally, you will find it. Next is input in color. So the idea of this is you would find the blue, for example, in day 4 is already there. You will find the day 5 come down and join, and that is symmetric. That is symmetric. And above that, the red color comes and joins. Above that, so you can see this triangle, this triangle plays a very important role. And you can see here, this is actually red triangle. Only thing is you would find that a small protrusion from the previous part. This is a triangle, a small protrusion from the previous part. That is all it is. Cool. So let us just do a deeper analysis. We will pick up one of them. We will pick up one of them and start working. We've already worked it out. We will work together. Okay. I made everything ready for you. Now, whenever you work on a pattern, remember I had said last time, you need to there are a couple of questions. Who controls rows? Okay, let me just put it across for you. Remember, okay, first thing, okay, who controls rows? Who controls the rows? You look at this. Okay, now for example here n is 6. N is 6. How many do we have? 1, 2, 3, 4, 5, 6, 7. So who is controlling my row? Okay, it is going to be n. How much do I have? I have n plus 1. I have n plus 1. Okay, cool. Next, who controls my column? Here, you look at it, there's a nice thing over here. The number of columns, actually, if you look at it from here onwards, from here to here, it is 1 for the first line. And second, it's going to be a second line. So you would find as the line grows, the column also grows. Let us say, for example, this is made up of 2 components. That is why you would find that this requires additional working. In the previous problem, all we did was we just had only 1 component, so there was no issues. But here, there are 2 components. What is that? This is made up of spaces and stars. Okay, so we will work on that as a formula here. The next is going to be okay. Next question is going to be, remember what's the question? Next question is going to be, how do we move? Okay, how do we move? 1 to n or n to 1. How do we move? How do we traverse? Okay, two options for us, 1 to n or n to 1. In this case, as we are going from n plus 1, you would find we will be moving from 1 to n plus 1. So this becomes my line number 1 or row number 1, 2, 3, 4, 5, 6 and 7. So this becomes my line number or the row number, however you want to call. Perfect. Pakka. Cool. Good. So now let us find out. For line number 1, so we'll have line number 1, line number 2, line number 3, line number 4, line number 5, line number 6 and line number 7. Let's just have this perfectly placed so that you will find that then we can count and fill it how things goes. So line number 1. Okay, so for line number 1, you look at it here, 1, 2, 3, 4, 5, 6. There are 6 spaces. There are 6 spaces. And for line number 2, 1, 2, 3, 4, 5. Okay, 5. I am going slow. Why? Because in the last pattern, I had one style of coding. And in this pattern, I am having a different style of coding. That is why I'm showing you everything step by step. So in line number 3, 1, 2, 3, 4. It becomes 4. And line number 4, 1, 2, 3. I think by this time you would have understood. It becomes 2, it becomes 1, and it becomes 0. Pakka? All is well? Cool? Good. Now, let us find out, is there any way by which we can make a formulation for that? That is going to be the crux of it. Okay. Let me make it a little bolder so that people who are using a mobile phone, you will be able to have a look at it and format painter for this also. So my idea is, my question is, see, with whatever we have, can you make a formula? We have n, we have line num, and we have spaces. Okay. So how can I make a formula? These are the things I have. Whatever on the screen, I have n, line number and spaces. So one option you can see here, n and spaces are connected. N and this. Okay. And then it becomes 5. So how do you think you can make a formula? Fine. Remember last time if you remember my program, I'll show you my program. I would have said spaces is equal to 6. And after that, every iteration, I would have been reducing the spaces 5, 4. But here, I'm trying to make a formula with the existing. For every time, spaces have to be calculated. Okay? Pakka? For every time, spaces have to be calculated. So, how do you think that can be done is the question. So, take some time. No problem. Take some time. Absolutely no problems. Take some time. Okay, cool. No problems at all. Fine. Okay, relax. Fine. Look at it. I want a formula. We need to create a formula where every time that has to be calculated. That is all. Okay. Now let us find out how can that be done. I need, look at it. I have n here. I have line number here. I have 6 here. So how can we make 6 from this? The best is to have 4. I have line number is 3, n is 6, and I need 4. Line number is 6, I have 3, I need 4. Okay, it can say n minus line number plus 1. It makes it. Does it make it for sensible for us? 6 minus 1, 5 plus 1. Wow, it makes it. 2. 6 minus 2 is 4 plus 1, which means my formula for this can be made into, okay, n minus line number, okay, plus 1. Cool. To get my spaces, this is an awesome formula. Now let's look at the same case with, okay, so let's copy this and paste it. Okay, line number. What about stars? So for line number 1, I have 1 star. Okay, cool. And for line number 2, I have 3. For line number 3, I have 5. And for line number 4, I have 7. Okay, line number 4, I have 7. And then for line number 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think by this time you would have got the 11 in the formula, 11 and 13. So once again, using line number and whatever is available, how would you get the number of stars? Okay, there are many ways actually. You can just, honestly, there are many ways. Okay, but I want something very similar. Okay, look at it. Using n, using line number. Any possibility? 1, 3, 5, 7, 9, 11 and 13. I have 6. Okay, I want only 1. Or look at it. Line number is 1, stars. 2 and 3. Okay, so n I don't think is required over here. 3 and 5. 4 and 7. Okay, 1, 1. If I have 2, if I add 1, it becomes 3. If I have 3, I add 2, it becomes 5. 4 plus 3, 7. 5 plus 4, 9. 6 plus 5, 11. 7 plus 6, 13. Which means one formula can be line number plus line number minus 1. One option. Got the point? Line number plus line number minus 1. Any other option? 1 and 1, 2 and 3, 3 and 5. The other option can be line number into 2 minus 1. So we can have either option. We can just say here line number into 2 minus 1 or into 2 minus 1, or the other option is you can also have one more formula which can just say line number plus line number minus 1. Line number plus line number minus 1. Okay, all is well. We have two options. We can use either one of them. Okay, cool. Done? Good. Now this means this is easy for us. This is easy for us. We can generate this. Okay. Now, got it. There's something very interesting. That's very, very interesting. In this analysis, just keep this. You look at it over here. Find 1, 2, 3, 4, 5, 6 and 7. Sorry, 6. Okay. So we have 1. We have 6. That's much better. We'll have a much more bigger one. We have 6 here. We have 6 here. Cool. We have it. So that would be much better for us to calculate. So let me make it visible for you. Okay. Let me make that visible. Okay. How do I make it smaller for you? Fine. Cool. I think it's visible. Okay. So let's look at this. I'll make it bold before we start typing it so that it will be perfectly visible for all of us. Now this is why you will find that you need to spend enough amount of time in doing your work on paper. So I have 1, 2, 3, 4, 5, 6 and 7. N is 6, so we have 7. And if you look at your branch, okay, it actually requires what we did in line number 2, 3, 4, 5 and 6. You do a clear match. You would find what you have here is exactly what you want as the next part. Then once again you look at it. So this becomes 2, 3, 4, 5. It becomes 2, 3, 4. It becomes 2, 3. And last one, leave it. So if you look at the true pattern, the pattern goes 2 to 7, 2 to 6, 2 to 5, 2 to 4 and 2 to 3. I'm leaving out 1 because it is done only once. Look at how have I presented 2 to 7, 2 to 6, 2 to 5, 2 to 4, 2 to 3. Are you able to understand? the 1 can be left out because it is not to be repeatedly done. The things to be repeatedly done are, focus please, this is one of the most important. I can bet you will find that you will see the most shortest, sweetest code. If you get this into your brain, the true pattern is, this is one pattern which is from 2, 3, 4, 5, 6, 7. I'll put it in some color. Then I have 2, 3, 4, 5, 6. I have 2, 3, 4, 5, 6. Let me have another color for it. Say green. Then I need 2, 3, 4, 5. Let's have a blue. Okay. And 2, 3, 4. Let's have a milder light. Okay. Fine. No problem. And then 2, 3. So, if you actually look at it, the true repetition happens in, cool, yeah. The true repetition is 2 to 7, 2 to 6, 2 to 5, 2 to 3, 2 to 4 and 2 to 3. Once you have taken this inside your mind, time to go. Time to go. And once again, even if you have never done even a simple looping, please listen to the next 10 minutes as to your life depends on it. Okay, shall we start? Okay, good. So hash include stdio.h int main return 0. So now this pattern fundamentally is made up of two things. Either I am printing a space or I am printing a star. This pattern is made up of either printing a space or printing a star. Fine. Not one space, one star, many. How many? Let us have a look at it. For example, how many do we need in case if it is going to be line number 1 or line number 2? Depending upon that, we have a calculation. So what are the various identifiers we need? We need to have n. And then we need to have one line number. Okay, let us just imagine my line number is 3. So for line number 3, what should be my number of spaces? What should be my number of stars? Okay, so let us just say for call is equal to 1. How many should we do? You remember the formula what we have done for spaces? For spaces, we have done, our formula is n minus line number plus 1. And for stars, line number into 2 minus 1. Okay. So let us come back and put it over here. Okay. It's going to be column should be less than or equal to n minus line number plus 1 and call plus plus. Same thing I can reuse my loop for the next set of stars. And what is the control there? Control is little different. Control is call less than or equal to, okay, 2 into my line number plus 1. Fine. Perfect. Now let us just test this whether this guy works for various lines. For line number 3, what should be my output? For line number 3, I should have 1, 2, 3, 4 and 5 stars. Let's just verify whether that goes well with whatever we have done. So file, save as. Okay, this is Christmas tree. So I'll call this as ct.c. Replace it. Okay, fine, no problems. Okay, so let's run this and see. Call is not defined, comma, call. Everything else defined? Yes, we have. So 4 spaces and 5 stars should be there. Okay, lot of spaces are there. It means n has not. Okay, what are we working on? We are working on n. So obvious n has got to be given. So n is going to be 6. Okay, that's what we did. Okay, n is equal to 6. So for n is 6, we need to have 4 spaces. Okay, there are 4 spaces. P, R, O, C. There are 4 spaces. But if you want to be sure, fine, if you want to be really sure, maybe we can, instead of having a white space, replace that with maybe a hash. Okay, so that hash would be helping us to understand exactly how many is going on. So 4, 1, 2, 3, 4, and look at that, 3, 5, 6, 7. So for line number 3, should we have 7? Let's just verify it. For line number 3, okay, look at it. For line number 3, I'm supposed to have only 5. Okay, but look at it. Line number 2, no, which means line number -1. Hold on. For line number 1, we need 1. Line number into 2 minus 1 will be 1. Line number into 2. This means we have made some mistakes somewhere over here. Have a look at it. So I have said, okay, line number equal to 3. So obvious line number equal to 3 would be giving 2 into line number is going to be 6 plus 1. It is supposed to be -1. Paka? Cool? Good. Now let's test it out. 5. Perfect. Now this has to be put into a loop. For example, for the first part, what are we doing? For line number is equal to, for line number equal to 1. Okay, line number should go on, how long should it go? Less than or equal to n plus 1, because n is 6, we need to have one more. So line num plus plus. Let's see how it happens in case if we do this. Okay, cool, pakka, good. Now let's just put this and say run and see how happy we are. Okay, oh my god, all is there, but what is missing? They are not going to the next line. Remember, this is our style. Change the environment. Whenever there is a line plus plus, immediately just say printf \n. Now, sometimes it would be a cultural shock for some of the people who haven't seen this. Dear participants, for is made up of 4 parts. First part is initial setup. Second is the condition. Third is a process that has to be repeatedly done. Third is a process that has to be repeatedly done. And fourth is change of environment. It can be subject, it can be objective change also. That is, it can be a change on, variables or identifiers. It can be a change on my interface. It is a change. Any change of environment can be nicely placed over there. Now let's run it. Got it. But we don't want to have the hash. Now let us replace that with cool, pakka, good, perfect. Now I want you to think. I want you to really think. If I repeatedly do this, remember, instead of line number 1, if I place line number 2, what will happen? It will go from 2 to 7. Now, if you look at the loop, what we have for 6, 2 to 7, 2 to 6, 2 to 5, 2 to 4, 2 to 3, right? So, if we can put this in a loop, and control this particular point, focus please. If I can have a loop over here, and if I can control my, just hold on, let me just do a small indentation. I hate this indentation, but I think we need some ID which will help me do some good indentation. Okay, that's being deleted. Okay, pakka. Good. So my question is, I want a loop who will help me. Look at it. 2 is always the same, which means line number is equal to pakka. Focus, 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 focus. Line number is 2 is going to be the same. But 2 to, this guy is working 2 to 7. Next time it should become 2 to 6. Look at it. Next time it should become 2 to 6. And then 2 to 5. And then 2 to 4. And then 2 to 3. Pakka. In that case, let us bring one variable who will reduce this guy's value. Focus. We will bring one variable. Okay, I'm sorry. We should reduce it. We should bring one variable who will reduce this value. First time, no reduction. Second time, 1 reduction. Third time, 2 reduction, and so on. That is all. Focus this. I want a guy who will reduce this 2 to 7 to 2 to 6. So first time, no reduction. So I can just say here, for reduce is equal to 0. And how long will the reduce go? Let's calculate. I should go down from, if it is 6, 2 to 7. Okay, 2 to 7. And then 2 to 6, 2 to 5, 2 to 4, 2 to 3. How many times am I doing? 2 to 7, 2 to 6, 2 to 5, 2 to 4, 2 to 3. 5 times I am doing. I am doing it 5 times. So I can just say here n minus 2. Now focus, focus, focus. In that case, how does it become 5? Starting from 0. Starting from 0. 0, 1, 2, 3, 4. Pakka. Reduce plus plus. Done. Cool. Let's run this and see. N is equal to 6. So let it be there. 6. Okay. Reduce have not been. Okay. I get sometimes. Run it. What is missing? Who would say reduce over here? Who would? That would come. Okay, Pakka. Let's just see what's happening. Now tell me what is missing. What is missing? The topmost part and the bottommost part is missing. That is actually, if you look at it, it's the same. It is the same. Look at it. It is the same. Look this. Look at this. Look at this if you wish to. This guy, I'm making it with a color. For example, not yellow, red. Okay. That guy and these guys are the same. So you can just write one code on the top, write 2 times down below. That is all. And if you are good in C, if you know printf properly, you can do it in one single line. Let me just do it. Look at it. How powerful. Of course, I'm not saying only C can do it. Every language has this facility, printf. Print formatted. You can specify a format here. So you can specify, for example, 6. Okay, percentage 6 C. Okay, and what do you want? You want to have a star there. Okay, 6C. You can just make it star. I'm just keeping it like this. Okay, I'm just keeping it like this. I'm just going to show you how it works. If it works, then we can make the correction. What do you mean by 6C? 6 means take a 6 character space. In that, place a star. So it will be 5 spaces and a star. Okay, you have to keep it outside. Tongue. Let's run this. Okay, what's missing? \n is missing. Okay, so put a \n. Here also \n. Last one not required. Let him be there. Tongue slightly missing. Make it as 7. Okay. I'm sorry. 7 and 7. So in a 7 character area, Okay, in a 7-character area, print. Perfect. Gels. Now you may be questioning, hey Sridhar, you have fixing up 7 over here, but that is not going to be my control. Okay, now focus. Now focus. This can be replaced by a variable. This can be replaced. When you say star, it means the value what is required in this particular place. Please keep your ears wide open. The this particular place, there is going to be a value, but that value is going to be coming down from a variable n plus 1. That is all. So just add this comma n plus 1. Now you can see how powerful printf is. That's it. Now let's run this and see how it works. Can we give 20? Why not? Enjoy. Stand is there. All is there, right? Pakka? Cool. Now, only thing is you would find that we just have to make those corrections. What corrections in the code? If the user gives 1, we have to give him a message. If the user gives 20, we have to give him another message. Else, we need to do it. So, let us bring that. Okay, fine. So, let us bring it as, okay, scanf %d, comma, address of n. Okay. And then we can just say here, if n is equal to 0, okay, n is equal to, cannot say n is equal to 1, n is less than or equal to 1, because possibly they may try with 0 also. You can say here, printf, let's use the exact message, whatever they said. Okay, what have they said, what have they said, what have they said, what have they said? They have said, okay, you cannot generate Christmas tree. Okay, you cannot generate Christmas tree. So let's just take on this. You cannot generate Christmas tree. Okay. Okay, good. Else, in case if it is greater than 20, else if my n is greater than 20, then we need to have another message, printf. Okay, sorry, I just forgot the message. Tree is no more. Tree is no more. Okay, just say here, tree is no more. Okay, cool. Else do this. That is all. Else do the entire thing. That is all. To this point. So you look at this code, actually you'll find that, okay, this has been initially, this is all the code is. Fine. I know most of you would have taken a photograph. Good, nothing wrong. I'm perfectly fine with it. Don't ask me to send the code, that's all. Fine, that is all. Now it is 100% perfect. Let us try with some simple numbers. Let's try with 2. Okay, something wrong? Yes. Fine, for 2, it becomes wrong. Okay, 2, what should happen? Let's just have a look at it. For 2, it should be something like this. Okay, so what's happening? Minor tweaking. Let us just check with 3. Always test the data. Okay, let's check with 3. Okay, so let's just check with 3 before we do any debugging. Okay, check with 3. 3 works perfectly. No, 3 also has got subtle trouble. Okay, 3 is supposed to have 2 layers. 3 is supposed to have 2 layers. So which means the formula has got to be little tweaked. Okay, let's have a look at this. Look at this. Okay. Okay. So what happens over here? N minus 2. So should that be, look at it, I'm giving n. Okay, this should be n minus 1. Why? Look at it. 0, n is 2. Reduce is 0. Reduce less than n minus, that becomes 0. Obvious, it won't happen. Obvious. Now let me give me 3. And it works. Paka. And if I give 2, nails. Cool. Okay, now why why I did it? I did this because if anybody wants to say anything, you can speak. Okay, why I did this? Because if we give huge numbers, it will be very difficult for testing. That's why I tried. Okay, I tried huge numbers. Everybody would have been happy. Wow, it's working. But best thing is to try all the n's. Now let's also try out for 1 and 0. If I say 1, you cannot generate Christmas tree. That works. Okay. If I say more than 20, if I say more than 20, for example, 22. Okay, tree is no more. Okay, looks okay. Now let's have a look at that code. Okay. Okay. The initial part is not required. Okay, all this is built fundamentally this is the most important part. Look at this code. Let me explain this once again. The first printf. In the first, okay, now what did we do? This, when you look at it, everybody, most of them, I would say most of them get carried away with this structure. That is, the first one, this they handle separately, and this second part is 2 difference, and after that they have been handling 1, 1, 1. This is how everybody have been thinking. But the true symmetry, the true pattern comes in this area. Which area? Let me just show in the okay. Remember 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 2, 3, 4, 5, 2, 3, 4, and 2, 3. This is the true pattern what is to be drawn. Rest of them is another pattern having 1 star and 1 star, 1 star. Even they could have just given 1 more, that's the stand becoming 1 more. Or they would have done, for example, I was thinking about it, the stand also should grow depending upon the number of days. Every 2 days you should have 1 more. For that makes sensible for me. Okay, if you ask me, I would have done it. For every 2 days, lengthen lengthen the body. The stand becomes 1 more longer. So for 6, it will be having 3. For 8, it would be having 4. For 7, also 3. Every 2 days, it will get extended. So you will find for 20 days, the stand also will be strong. Here, look at the stand. When I just try with 20, stand is weak. Sounds not a good engineering. So next time, when somebody makes a problem, ensure that is being done that way. Look, such a huge tree. Beauty. Got the point? All is well? Paka? Good. Okay. So, look at this code and then we will go down to the next problem statement. Next problem is going to take just 10 minutes. And after that, let me just show you collectively all the codes, whatever we have done till this point. I have everything aligned. You can just see here, I have all of them aligned. So I'll just show you everything and then we can wind up for the day. Paka? Okay. So summarization. Okay, good. Printf. What is this importance of printf? Here, I would like to have n spaced, and in that space, I want to have 1 character. So the format specifier percentage, for example, you can have a number. Okay, 10C means 10 character and a star would be there. Paka, go through this code. Yes, anybody who wants to speak, you can speak to me now. All is well? All is well? Paka? Done? go through that. I'm sorry, I'll remove this code. So we did this first of all, one simple loop, okay, and then we made them into a loop, and then we made them a loop around that, and the entire tree was over. What was missing? The top portion and the bottommost portion was missing, and that we had a separate way of handling over. Paka, done? Good. So we'll move to the next statement.